Hi and welcome to your next lecture in Computer Science for Everyone. We're still talking about collections, but this time we're going to introduce the concept of array lists. So what is an array list compared to an array? It is pretty much the same thing in that elements can also be modified. However, you don't have to worry about the size because the size of an array list is dynamic. This means that whereas in an array you would define either explicitly or implicitly the size on declaration of the array, for an array list, you do not have to declare its size. So you simply create the array list and then you start adding and removing elements and the size changes as you do that. So you don't have to worry about the size of the array list. This is especially useful, for example, in games. For example, the asteroids game, where you navigate a ship around an asteroid field, and asteroids can enter the field or your screen at any given point in time. The programmer doesn't know beforehand how many asteroids are going to be in the screen because it depends on the user destroying them. So having an array list for the asteroids themselves that are in the screen is better than an array because you can add and remove asteroids on runtime without having to previously know the size of the array list. Of the array. So this is why we use array lists and not arrays, as well as many other reasons. So how do we create an array list? It is a bit different than the array, so please bear with me for a second as I try to explain. So the first thing we have is a list, and then the data type that's going to be stored in this list, and then we have the name of the list, and then equals new array list, and then once again between crocodile clips the data type we're storing, and then two brackets at the end, just like when we're creating any object. So the one difference here, well, there are two differences. The first one is that we have to specify the data type we're storing in this list in between crocodile clips, both at the beginning and at the end of our object declaration, but before the brackets at the end. So this is one thing you'll have to remember, and this is how Java deals with the ability to give it different data types. So surprisingly, for this class or for this array list objects, you can store many different data types in it. And this is a part of Java called generics, and it is a functionality of the language that lets you store different data types on a class that's programmed to hold many different data types. However, it implies a few problems as well. For example, it can only deal with classes, not primitives, for example. So this is how you would create an integer list. So the fact that Java can deal with, well, this object can deal with many classes, such as string or integer or double, also implies that you cannot use primitives with it. So instead of int, you have to use something that's called a wrapper class, that is integer. Or instead of double with a lowercase d in the beginning, you have to use double with a capital D. So those are no longer primitives, but they are the wrapper classes for primitives, and we'll see what they do in a second. So as we know, primitives such as int cannot be used with lists. And this leads very nicely onto the next problem, that is, we have list in the beginning, but array list at the end. This is not as we know it usually when we're creating objects. When we created objects before, both the object name at the beginning, the class name at the beginning and at the end have been the same. So why do we have list here? Well, the truth is, list is something that's called an abstract class, and you cannot create objects directly from an abstract class. So how can we create an object that's different from the object that's at the front? ArrayList as a class comes from the list class. So the ArrayList has all of the functionality of the list, as well as some more. So we can treat effectively an array list as a list because the array list contains all the functionality that list has. Therefore, if we're going to perform on an array list object any function that a list has, that is something we can do, and Java knows this is something we can do because ArrayList has all the functionality of a list. Okay, so then why don't we put just ArrayList in the beginning? Well, because what if there are many different types of list? All of the different types of list, let's call them, for example, ArrayList and linked list, as we'll see in the future. All those two different types all have the same functionality as a list. Although you might originally think that ArrayList is the better choice, you might come across that actually linked list is the better choice. And you might start writing other parts of your program using linked list instead of ArrayList. If you use ArrayList in the beginning, you are stuck with ArrayList. If you use list, you can switch to other, as we call them, implementations of list. And such implementations are ArrayList and linked list, as well as others. So using list in the beginning is something optional that it doesn't really matter in small applications, and you can use, if you want, ArrayList in the beginning and at the end. However, I'm trying to teach the good practice here, and if someone else is going to potentially work with your program, you want to use list so that you can swap to other implementations of list. If only yourself are going to work in the program, it doesn't really matter. You can use ArrayList, and it potentially even is a tiny bit faster. But that is why ArrayList and linked list both are types of list. They are, as we call them, subclasses, and we'll see what this means later on. So this is why we use list in the beginning and ArrayList at the end, because we are creating an ArrayList that comes from a list. As we've seen, int, double, float, long, char, and boolean are primitives. This means they are built into the language and they are not objects or classes. However, as I've said, there are integer, double, float, long, character, and boolean with capital at the beginning, and these are classes which are not primitive. They are wrapper classes, and they have some functionality like the following. Integer with a big I, dot, parse int, and then we give it a string. This converts the string to an integer. This is a fairly useful, actually it's a really useful function, so that we can convert, for example, something the user gives us as a string into an integer. Or for example, this integer to binary string 156 converts an integer that we give it between the two brackets to a binary string, such as 1010 or something along those lines. Other primitive classes are similar to the integer class. They contain pretty much the same functionality, only that instead of string to integer, it would be string to double or string to long. As I've said, we cannot use primitives with ArrayLists, so we have to use their wrapper classes instead, such as double with a capital D or boolean with a capital B. In the next video, we're going to be going over programming some ArrayLists. So stick with me and let's go into the next one and we'll clear out any doubts you may have.